Have you ever paused to truly consider how utterly pervasive the internet has become in our lives?
Oh, constantly.
I mean, from sending a quick message or an email to streaming your favorite show or, even attending online classes like so many of us did during the pandemic,
Mm-hmm.
it's just there.
Mm-hmm. We rely on it for almost everything.
Exactly. But here's the central mystery we're diving into today. When you hit send on a message or click to load a video, how many other devices does that information really travel through?
Right.
Beyond just your phone or laptop and the recipient's device,
Mm-hmm.
what's actually happening behind that digital curtain?
It's a truly fascinating question, isn't it? What's often completely unseen is the incredibly intricate network that connects potentially dozens, maybe even hundreds of computers for even the simplest communication.
Yeah.
Our deep dive today is all about pulling back that curtain, sort of unraveling the layers to answer the fundamental question. How does the internet actually work, and why is its design so ingeniously resilient?
Absolutely. Our mission today is to explore that entire journey of information on the internet. We've drawn some really incredible insights from an in-depth animated video designed to beautifully demystify this complex system for anyone curious about how it all works.
Sounds great.
So let's delve into this.
Hmm.
At its most basic, the internet is defined as an interconnected network of computers around the world. Sounds simple enough, right?
Seems simple on the surface.
There's a bunch of computers chatting to each other.
But the immediate complexity quickly becomes apparent. Imagine if you tried to connect every single computer directly with wires. It would become an impossible tangle, incredibly fast.
Oh, I can picture it. A mess.
Think about it. If you only wanted to connect just 10 computers directly, you would need a staggering 45 cables.
45 for 10 computers. Wow.
Exactly. Now, scale that up for thousands or even millions of computers. It's an immediate physical nightmare. It just wouldn't work.
So, okay, with that seemingly impossible tangle of wires, how did we actually make this global network work?
Good question.
This is where our unsung hero, the router, truly steps in as a key solution to this immense complexity. You can think of a router as being like a small, specialized computer.
That's where the magic starts. Its core function is quite similar to, say, a railway station signal.
Okay.
Just as a signal gives trains green or red lights to tell them exactly where to go, the router ensures a message goes in the correct direction.
Right. Keeps things on track.
Precisely. It meticulously guides that message, making sure it reaches the right device and doesn't get misdirected somewhere it shouldn't. It's basically the traffic controller of the digital world.
That's a great analogy. So a single router can manage a local network, maybe in a home or office.
Exactly.
But how do we scale that up to connect entire cities or even continents? What's the next layer of this network?
That's where it gets truly interesting. While one router works great for a few computers, multiple routers can be connected to each other, forming a vast web. This allows for what are essentially infinite connections, letting us build a truly huge network that is surprisingly close to what our modern internet actually looks like on a foundational level.
Fascinating. So we've got this interconnected web of routers managing local traffic.
Mm-hmm.
But that's still just the digital side, the logic.
Mm-hmm.
How do we physically extend this network
Mm-hmm.
beyond a local set of connected routers to a truly global scale? That must require truly massive physical infrastructure.
Precisely. You've hit the nail on the head. To connect networks across vast distances, we need a colossal cable infrastructure, stretching across continents and even laid deep under oceans. Huge undertaking.
Oh, wow. But what's truly clever here, as the source points out, is that we didn't have to build everything from scratch, did we?
No, that's a key point.
We could actually leverage existing infrastructure to deliver the internet, like the very same telephone lines that have been around for decades.
And that's where the modem comes in. Its specific function is to take those analog signals from the telephone lines, which are essentially sound waves, and convert them into the digital signals, the ones and zeros, that a computer can actually understand and process.
So it's a translator.
Basically, yeah. Without a modem, your computer would just hear a lot of noise from the phone line. It wouldn't make any sense of it.
Okay, so you've got a modem connected to your computer translating those signals. But you're still not quite online, are you?
Not yet.
Simply hooking up a modem isn't enough to actually get you on the internet.
There's another piece.
Not at all. This is where internet service providers, or ISPs, play their absolutely crucial role.
Ah, the ISPs.
Companies like, say, BSNL or Airtel, for instance, are ISPs. They operate by having their own vast networks of routers,
Okay.
which are in turn connected to other ISPs routers across the world. This massive interconnected infrastructure of ISP networks is collectively what is the internet.
So it's a network of networks.
Exactly. And what's truly profound about this interconnected web of ISPs is that no single entity owns the internet.
Right, that's important. This decentralization is both its greatest strength, fostering innovation and resilience, and occasionally its biggest challenge, maybe in terms of global governance or regulation.
That's a powerful insight. So, okay, we've set the stage, we've laid the infrastructure, routers, modems, those huge cables, ISPs connecting everything.
The building blocks.
Now let's talk about what all this means when you actually load something on the internet. With all these pieces in place, how does it actually translate into our daily experience of, say, loading a YouTube video?
Right, good example. When you want to watch a YouTube video, that video isn't just floating in the ether somewhere. No, it's physically stored in massive data centers. For instance, the source we looked at mentions one data center located in Mumbai. These data centers are full of powerful servers all connected to each other and, in turn, to other servers globally. Huge buildings full of computers.
Okay, so the video lives on a server in a data center.
Yeah.
So the first step your browser takes when you type youtube.com is what? Needs to find that server, right? It needs to find the specific IP address of the YouTube server. And this is done through something called a DNS directory. That's the domain name system.
The internet's phone book.
Pretty much. Think of it as the internet's global phone book, translating the human-readable website name you type, like youtube.com, into the actual numerical IP address that servers use to communicate. It's like finding the exact house address of that server.
Once that numerical IP address is known, then your browser can establish a direct connection with that specific web server. It's almost like dialing a phone number and finally getting a connection.
And for all these requests and responses flying back and forth, there's a critical set of rules, right, or protocols that must be followed.
Absolutely critical.
These aren't just polite guidelines. They're the agreed-upon languages and procedures that ensure devices can actually understand each other. The source specifically highlights TCP/IP.
Right, which handles the reliable breakdown and reassembly of those data packets we'll talk about.
And HTTP, the Hypertext Transfer Protocol, which is like the foundational protocol for how web pages and content are delivered across the World Wide Web.
Exactly. Those protocols are the grammar and vocabulary of the internet. Now, when you request that video, the server doesn't send the entire file all at once. That would be really inefficient.
Okay.
Instead, it chops the response into small pieces or packets of data. These are essentially binary bits of data. The fundamental ones and zeros that all digital information is made of.
Tiny little pieces.
Tiny pieces. And what's truly ingenious about these packets is that every single packet knows its destination IP address, and it knows which other packets it needs to join with to reassemble the complete video on your end.
That's clever.
It is. And this packet switching isn't just a clever trick. It's the ingenious design that makes the internet incredibly resilient. Think about it. If one path gets congested or even breaks, those tiny packets can find an alternative route, ensuring your data still gets through, maybe just a little slower. This is why the internet almost never truly goes down globally. It just reroutes itself.
That's a fantastic point about resilience. It's built to survive problems. So, okay, let's trace that full YouTube video request journey again.
Let's do it.
Your video request is first chopped into these tiny packets.
Yep.
These packets then travel through internet cables, hopping across different routers, owned by different ISPs maybe,
Potentially crossing continents.
until they reach the web server where the video is stored, say, in that Mumbai data center.
Right.
The web server then processes your request and finds the video file. And even though YouTube is massive and has countless videos, this process happens in, what, mere milliseconds?
Incredibly fast, yeah. Usually milliseconds.
The video is then sent back to you as a response, also chopped up into packets.
Same process in reverse.
And these packets can arrive in different ways, maybe out of order, taking different paths.
Exactly. They don't have to follow the same route.
But your computer diligently reassembles them. It prioritizes elements like the HTML structure first, then the CSS styling, the JavaScript for interactivity,
Builds the page structure.
which kind of lay the groundwork before the larger video stream itself begins to play seamlessly and appear on your screen. It's an incredible choreographed dance of data happening constantly.
There really is something.
So what does this all mean for us? I mean, a seemingly simple act, like watching a video online, involves this incredibly complex dance
Mm-hmm.
of routers directing traffic, modems translating signals, ISPs providing the global infrastructure, and these tiny data packets just zipping around the globe,
Yeah.
all to reassemble perfectly and seamlessly on your device.
And what's truly fascinating here, I think, is how grasping this intricate infrastructure transforms our daily interactions with the digital world, understanding not just what happens, but why it happens this way. Well, it helps us appreciate the engineering marvel that connects us all.
Yeah, definitely gives you a new perspective.
It really reinforces that knowledge is most valuable when it's truly understood and applied, giving us a deeper appreciation for the technology we rely on every single day, often without a second thought.
Indeed. So the next time you send an email or watch a video, maybe remember that central mystery from the beginning.
Mm-hmm.
It's not just your device and the recipients. Take a moment to consider the incredible unseen journey of those binary bits, a truly intricate system working seamlessly in milliseconds to connect us all. It's a silent, global ballet happening right beneath our fingertips.